evening to everyone. Welcome to the Emertxe Iot project internship. Today I am going to present about the group presentation and myself Madhavan B. I am going to explain about the embedded C and the Arduino code explanation, and my teammate Nagaarjun will explain about the project implementation and the Blink integration explanation. Let's go to the introduction. Let's start the introduction with the C. What is C? C. Have you ever seen responded how powerful it is, efficient, flexible, and deep? Powerful is about the language, and efficient is how it's used and the time complexity. Flexible is about the code that we have to implement. Deep, you can explore your system, that you how to interact with your system and using the code. Let's see now how the C programs are used. See where it is used. System software development and embedded software development and iOS kernel development, and as well as the Firefly middleware and the driver development, and also used for the file system development and many more there. Let's see the important characteristics of C. It is a general purpose language, even though it is applied and used efficiently in various specific domains. It is also a free format language. It is also like an open source, and is a efficient and also efficiently under portable are the important considerations. Library faculties are placed that plays an important role. There are also facilities in the C program where I explained in the libraries. Next we see the following characteristics and also the key categories. Let's see the types, data types. The keywords are char, int, float, double, and also go through the modifier, signed, unsigned, short, long. Signed means only used for the plus operator. Unsigned can be used for both the plus and subtraction operators. And also come to the qualifiers, that is a constant and the volatile, and also loops, as well as the for while do, and the jumps, you go to the statement like go to, break, and continue statements. Let's flow to continue to the decision like if else, switch case, default statements, and also storage classes like auto, register, static, and extend. And follow to the drive, there is a structured unions, and also there is a user defined, enums, and type defined, and others keywords like void, return, and side off. Let's go through the typical C constant, like content like documentation, uh, pre-process statement, also a global declaration. There is a main code statement. There will be a main code declaration like logical declaration, program statements, and followed by the functional calls. And there are also one or more many functions in a body for implementing the program for using efficiently. A typical code might contain the block so that on left. Yeah, it is possible. Like it is generally recommended to practice writing codes with all the blocks. The anatomy of the simple C code. Let's see the file header file like hashtag includes stdio and the preposition directive, and followed by the start program of the instrument, and also there is some commands to display hello world. For in using the print display statement, we use printf, like inside the double quotes we declare the hello world, and followed by the return statement to program determination return 0. If we go to the data representations, like data represents like a number system in embedded C, as well as the number system is generally represented as uh, decimal, octal, hexadecimal, and binary. We know that the decimal is by 10, and octal is by 8, and hexadecimal is like 16, and the binary is 2. Like the type where we describe the range of the bit, decimal 0 to 22 to 5, and octal is 000 to 0377, and hexadecimal and binary as follows. Here see the type and base. Uh, Decimal has 10, octal has 8, hexadecimal has 16, binary has 2. These are the tables for the binary values. Let's follow through the embedded representation like bit. Literally, computers understand only the two states, high and low, making it binary system. These are the two codes. 0 and 1s are the binary digit that represent to understand the codes for the machine. Binary digit give the birth to the word byte. Yeah, that's we know. Byte is also a basic unit of information in computers and the digital communication. There are also the values 0 and 1s, 0 and 1s, and number of bits also represented 0 and 1s. Next we see the byte. It is byte is also known as that the 0 and 1s are the called as a byte. We already see. Next we move on to the integer number. The integer positive means it represents it positive. An example that is given that the 13-bit system would be. And these are the position and values that we have lot. And also followed by the positive number, there are also negative integers. There is also an example of minus 32 in 32 bits, and there are also in the position and values that are already discussed in our represented classes. Next we see the basic data types. These are the data types like a character, float, or come to the integral, and the floating points are float and doubles are this is the data types. And these are the modifiers and the qualifiers that like the short, long, tongue, and signed and unsigned, and the constant and volatile. That's a conditional construct. The conditional construct is two single integration and double integration, as followed by the switch case, for case, and loop statements. These are the this is the index of the if condition and the flow graph for the, and there are also some examples that we are last taught. And followed by if else, that is also a syntax how to represent the program, and there is how the flow of work also given for the flowchart. Followed by the else if, there is also a example program, and we will come to the if else statement. This is a syntax format and the flowing graph of the if else statement, and followed by the switch statement. This is a syntax for the switch expression, case 1, case 2, case 3, etc., and also the flow graph of the switch case statement. And there is some few example for the switch case statement. The conditional structure we have like loops while. There is also flow graph for the how works, and there is also an example for that. Followed by the switch, continue with the for loop. There is a syntax for the for loop, and there is a flow of the for loop example, and with the suitable program. Like come to the statement like continuous statement. These are the flow graph and syntax for the continuous statement. Example for the continuous statement, how it works with the suitable. Example for the break statement and the syntax and follow code, and also would be the um, example code for well suitable. Then we go to the operators. Operators like the two operators, C in two digit operators on operand, and it also a return a value. Let's we go to the arithmetic operator as known as addition, plus subtraction, multiplication with a suitable example, and also a logical operator that logical not, logical and or with a suitable example. Next we go to the relational operator greater than, less or greater than equal to, less than or equal to, double equal to, not equal to with a suitable example as we see. And also with the flow of the assignment operators, there is a few examples to go through it. And next we goes to the bitwise operators. There is a bitwise and bitwise NOR and bitwise XOR, and also a complement, right shift, left shift. Next we go to the values and byte counts. These are how values and byte counts are works. We already seen in internship classes. And next we do the byte count as we follow the right shift and left shift. This is the value side for the values and the byte count, and followed by the language offsize operators, and the ternary operator also known as the conditional operator with the suitable example and the syntax. And we go to the over to the embedded C program over and overflow. Next we the signed numbers as we already see, and there is unsigned number also we have already discussed. Next we move on the topic of the array. Array is used to store different types of different types or different characteristics used to store the values like in array of numbers. There is also a limited access. Array is a collection of data as we also discussed in live classes, and also suitable examples why you are using array. and also used for storing how to store an array, and also initializing, copying, and the pointers. Pointers is used for low level and high level programming. It is used to point the values, and also is used for the 32-bit and the 64-bit like 4 bits and 8-bit systems. And there's also a reference and a reinforcing rules. Let's see the functions. Function mainly contains three parameters: input, output, and operator. Like these are the syntax for the function declaration and the suitable example. And also for how to write a function, how the function calls, and why we are using the functions. Already discussed in our live classes. And also a complete look how a function works in a C program. And followed by the how to ignore return values that using the statements. And there is a pass by values and pass by reference. And there's also example for pass value, and pass reference, and followed with advantages, disadvantages by passing array. That's a suitable example. The function that's a recursive function. A suitable example for the recursive function, how it works. Let's go to the segmentation fault with the suitable examples between pointers, and also will pointers, and also code qualifiers, and also a string. These are the characteristic how we use the string in our C program. Example for the C program, how it is suitable examples, how it works, and also there is how the libraries and the length of the operators they compare checking strings in follow. Next we go to store classes. Store classes use the kernel, Linux OS, PS and user space, and also the kernel space. It's a suitable example where memory segments is used to track the memory how they are stored. The data segment is also in the memory segment. The heap which is short, stack into stores, and storages are the different all we are discussed in previous. And also suitable example for the storage classes. Declarations. These are the proposals. It is a header file includer, and it is a hashtag and a sig, and the include file was shown. And we'll go through the example. Then declare the indefinite and define, and also a macro object. There are also a suitable syntax and examples. Then we go to the macro arguments, also examples for the how it declared, and following with the suitable example for the multiple lines and standard predefined. I hope you understand how the we. I know we reversed what we are declared and initialized in live session, where we go through the little promo and have a little revise what you have learned in the embedded C programming classes. Thank you by Madhavan and Nagaarjun. As we go through the LDR, LDR is a diode, light dependent register. With the, for the Arduino code, let me see the defined the LDR A0 is a analog 0 pin, and defined with the LED 3 as the output pin. And followed with the white setup, we implemented the pin mode. We have selected 3rd pin as the output, and following with the unsigned using by the data type int with the light intensity, and also calculate the duty. Let's move on through the while loop. In while loop, we already declared the light intensity in outside the while loop, so we can be used inside the while loop. Here the light intensity is equal to the analog read LDR, which takes the input read, and the duty also declared that 255 minus light intensity divided by 4 as the formula, and analog write digital comma LED comma duty, which is displays the value with the delay of 100. And this is the example program Arduino code for the LDR. Next we move on to the temperature Arduino code program. Here you use the header file, they include hashtag include while.h, and followed by the liquid crystal I2C.h, and we also initialize the liquid crystal I2C LCD to display 0 cross 24 for 16 comma 2, which is represent for the 2 cross 16 LCD. And also following the, let's come to the program that represents the float temperature. Here we going to do declare the temperature, and follow the string temp. Temp is a string temp, and inside the white setup we declare the HC.int and for light, black light, and for to clear, and LC.home, and also a set sensor we declare at 0 comma 0, and we also use the LCD dot print temperature to finally print the temperature. Inside the loop we get the temperature as an input, like use the analog read A0 pin and followed with the formula of float by divided by 0 to 4 and divided by float of 0.01, and to display the temp we use the string with the function of temperature comma 2, and also the LCD dot set cursor with the 0 comma 1, and also the LCD dot print temp are declared to print the LCD value, and delay are given for the 1000. This is the Arduino code for the temperature program. Let's we finish with the one more example in that in our live section. It's a serial character, and also the defined with the header files hashtag defined for inlet and outward wall, and also defined by enable and disable. Let's come to the program. The white setup is giving the baud rate of serial.behind 19,200, followed with the white loop. We also declared the serial rate and inlet wall, and which inlet was to be enabled at the delay of 10,000, and also followed by the serial dot rate inlet wall, serial dot rate disabled. Next, it completed with the delay that we have given is 10,000 delay. This is the example program for the serial tank test what we have implemented in a live section. So I completed with these examples with followed by the Arduino codes. Next, my teammate Nagaarjun will explain the project implementation and the link integrated explanation. Thank you.
I am K. Nagaarjun. I hope my friend Madhavan explained the first part of Emertxe Iot called the internship slides like Emertxe and Arduino codes which we are implemented in this internship. Now here I'm going to explain the next part. So that is the link app integration and the overall project implementation of this embedded IoT project. So let's begin this. So first in this immersive training project document, so we are here to see what is we are going to implement in this internship. So that is a IoT based home automation solution. That is a basic project idea we are going to implement in this emerge emerging internship. So first let me see let me see what are the things we are going to implement in this. So for first, we are going to implement one garden lighting control through LDR sensors. And for second, we are going to implement the temperature controlment system. So for that, we are going to use LM35 temperature sensor. So which will act as it is an analog sensor. So the result of the temperature will be seen in the CLCD screen. So by controlling the temperature of a system by turning on or off the heater and cooler through Blink IoT app. So here are some requirements. First is temperature control system, cooler control system, heater control system, and threshold temperature control. And then the next we are going to implement is water tank inlet and the outlet valve control. For this, we are going to have the two control, one for inlet and one for outlet. The output of this serial tank will be displayed on the CLCD screen. So here are the requirements. We need here also we need three components. One is to display the volume of the water in the tank, so which will be displayed on CLCD, and one pin for a inlet valve control and another pin for outlet valve control. So and then we need to interface with the Blink application in order to control remotely so that it can display the sensor data and it can store data and visualize it and do many other cool things. So this is the overall project view. This is a overall overview of how the project we are going to implement it. So let us see the Blink app integration once. So continuing with the Blink app application, first we need to log in with our email ID in Blink app, and then we need to create one device name. So in here, I created LED internship as a device name. In that, we need to go to developer tools. So in developer tools, there is a column called data streams. In the data streams, we created six virtual pins f- for our project. So the first pin V0 is for heater control, and V1 is for temperature control, and V2 is for cooler control, and V3 is for volume of water in the cereal tank, and V4 is for inlet valve, and V5 is for outlet valve. So we need to implement these six virtual pins in Blink app in order to connect with IoT with our project. So this is the Blink app explanation. So next we are going to see the Arduino code integration. So coming with Arduino code integration, first we need to declare the Blink template ID and the Blink template name and the Blink authentication token in order to connect this project with Blink. So these are some of the libraries which we need to implement in our project. So first one is SPI pins and the Ethernet connection and the Blink Simple Ethernet library and wires LCD and the LCD declaration, and then we here we have the every components for each and every components we have here the code for it, and we coming with the LDR and main.h, and for temperature system we have separately, and finally we have volume of the water tank which is known as a cereal tank. So we need to declare them in one line, and then coming up with uh, this is a control for this is a control for cooler and heater pins to control the temperature system, and coming up with so these are the control for enabling and disabling the uh, water valves. So that is inlet valve and outlet valve. And for temperature reading, we need to get the temperature reading from this file to our main file. And for volume of the water, we need to take from this serial tank file to our main file. And then we have one function called handle temp. So this function implement if the temperature is greater than 35 degree, the heater control will be automatically off, and we need to, and it cannot be on if the temperature is more than 35. So for that we are implemented this function. And same for cereal tank. The overall volume of our cereal tank is 3000 liter. If the volume is less than 2000 liter, the inlet valve will be automatically on. If the CL tank is filled less than 2000, the inlet valve will automatically on uh, to achieve the to 2000 milestone. And then we have here a void setup. So from where we need to initialize all the components we are using in this project. So first coming with the LDR temperature system, and for LCD we know that initialization backlight clear home scissor cursor we know to print the text in the LCD, and finally we need to initialize serial tank, and we need to set the interval to update the temperature reading in the CLCD, and we coming up with void loop function. We have the blink run and brightness control. Brightness control is nothing but LDR. So Why should we give this in loop means we need to we need to update the controls for every operations we are performing in the particular project. So for that, first we need to implement brightness control to control the LDR sensors, so which will be acting as the garden light control, and coming up with temperature as we already know. So if the temperature varies, we need to update it on the link up also, so that we are calling the function in the loop function of the main program. Same for serial tank, so it will be considered as volume, and then we need to print those values in the LCD for repeatedly. So we are include them in a void loop statement. So this is an overview of how our project is going to implemented with Blink Up IoT, and this is the important step. Don't forget to add our Blink template ID, template name, and authentication token. So, which will be important to access our project via IoT. So, this is about our Arduino integration. So, let's have a look at how the project actually works with the Blink app as well as the serial communication. So, for our output simulation, we are going to implement using a simulation app called a Pixin Lab. So, from where this is a Arduino, as we already know. So, I need to give the input file as input. So, these are the components we are using in this project. So, the first component is the LCD with I2C. We need to connect this with the appropriate pin which we given in the main program, and this one is for LDR sensor, and this is for heater control and the temperature control system, and this is Ethernet connection to get a connection for a link app. And for serial tag, we need to go to tools, and we need to click serial remote tank. And for connecting serial remote tank, we need to have one app called virtual serial port tools app. We need to install this and we need to connect with any serial ports of our laptop or computer. So, and then we need to connect the serial tank with the laptop. So, I'm going to connect it with COM2 and connect, and this connection is done. And then we need to go with I need to upload the hex file. I am just uploading the file which we have implemented in the Arduino IDE, and just uploading it, and you can see it. Wait a minute. Okay. So first it shows home automation in the LCD, and the serial remote tank will be on condition, because if it is less than 0, it will be automatically the inlet valve will be on. So, and then we can see the output of the first one to 27.34 is nothing but the temperature system, and in the bottom we have the serial tank configuration. First, I'm going to implement the temperature. First, I'm going to on my heater. If I on my heater, it will show here heater is on, and once the heater is on, the temperature value will be rising. Yes, you can see that. I will also upload the mobile app integration in the presentation. So as you can see, we, once the temperature value is more than 35 degree, the heater will be automatically off, which we implemented in our Arduino program. So that is what here you can see. And once the heater is off, so um, I'm going to enable the outlet valve of the cereal tank. So once I enable the outlet valve of a cereal tank, it will show here outlet flow on. So there is some mistake in program. I just written wrongly to leave it. So once I on the outlet valve, the water in the cereal tank will be decreasing. So once I off the outlet valve, once I off the outlet valve and turn on inlet valve, it will again it will going to increase the volume of the water in the cereal tank. So I'm again off the heater. I'm again off the inlet valve of the cereal tank. So this is a overall project, and for the garden lights, you can control here LDR sensor. We control if I give it 0, the LDR value is the LED is offed. So for a cooling system, so that now the temperature value is 31.74. If I on my cooler system, the cooler will be rotating. The cooler will be rotating, and the cooler is on, which will be indicator in the LCD screen. And we can see in the LCD that the temperature value is decreasing slowly. And once it reaches room temperature, I'm off the cooler, and now we can see it is working fine. So this is a overall implementation of our project. So so that's it, guys. This is a overall project explanation and the link up integration of our IoT internship, which is conducted by Emertxe. And a huge thanks to Emertxe for giving this opportunity. And thank you.